This video will illustrate how we evaluate a limit. I apologize for the background noise in this video. I'm not sure what is causing it. Suppose we have a function y equals to f of x, and the function is x squared plus 4x plus 12. Suppose we want to evaluate the limit at x equal to 5. The left side limit means we have to take values smaller than 5. So 0 up to 4.99, this is our x values. And we calculate our corresponding y values. So that means 4.999 squared plus 4 times 4.999 plus 12. And we get these values. So as you can see, our y values goes from 12 to 56.896. So it gets closer and closer to 57. So we say the left side limit approaches 57. We do the same from the right hand side. So we need values larger than 5. So 5.01, 5.01, 5.1, 5.5 up to 10. And if we evaluate the corresponding y values, we get these values. So again, as you can see, it goes from 152 to 57.014. So again, the values get closer and closer to 57. So the right side limit is also equal to 57. So the limit, we say the limit approaches 57 from both the left and the right. If we evaluate the function at x equal to 5, that means 5 squared plus 4 times 5 plus 12, we get 57. That means the limit of the function at x equal to 5 is 57. If we look at another example where we have the function v, so y is equal to a function of v, and the function is 4 minus v squared divided by v. So if we evaluate this limit at 0, so for the left hand side we need negative values, which is smaller than 0. And we take this up to negative 0.01, and from the right hand side we take from positive values up to a value close to 0, which is positive 0.001. We calculate each of these values for these functions, and as you can see, we get negative or 9.6 for negative 10, and it goes closer, but it turns negative and it becomes very large, close to 0. The opposite's true for the right hand side. So we go from negative 9.6 up to 3,999.99. So what can you say of this function? The function is not defined at v equal to 0. That's because we cannot divide by 0. That means the limit at 0 will not be equal to 0. The limit from the left is equal to negative infinity, and the right side limit is equal to positive infinity. Another way to illustrate this is if we simplify this function. So if we say this is also equal to 4 divided by v minus v. So what can we say about 4 divided by v as we get closer and closer to 0? This becomes smaller and smaller. So if you divide by a smaller number, the entire factor becomes larger and larger, minus the same value. So that means our function will have a very large function minus a very small function, or if we approach it from the right, this will become bigger and bigger minus a small function, small value, which means it becomes bigger and bigger. That means, so if we look at the graph, approaching from the left or the negative side, we get closer and closer to the y-axis without actually touching the y-axis, and this continues into infinity. From the positive side, it comes from a negative value closer and closer to the y-axis without actually touching the y-axis, and therefore it goes to positive infinity. From the left, it goes to negative infinity.